Okay, I did receive a number of panicked emails and messages on Discord, and that is my fault. I'm sorry. Couple of issues. I put in all the I migrated the runestone grades over to Canvas, but there were a number of issues that occurred that I've hopefully rectified most of them. First, I migrated over some stuff that wasn't due yet. Second, so I've hopefully deleted most of those. Second, some of the stuff wasn't graded, and hopefully they're graded now. Like the chapter 7 readings, those should be graded now. Those apparently weren't graded. And then the chapter 2 quiz didn't correctly grade for a lot of people. Or sorry, the quiz 2, the turtles and for loop, didn't correctly grade for a lot of people. And so that was an issue. But if you did well on that should, for quiz 2 specifically, I made sure to go through all those and grade those, as well as fix all the issues for quiz 1. So all the quiz grades should be up and current, as opposed to last when I ran it on Sunday and they were not correctly migrated. So so now with regards to the chapter 9 and 10 are migrated over, but it's fine if you haven't. I mean, what are they due yet, or I think they're due later?
I know that chapter 9.
Let me check the assignments.
What I got for it was a lot lower than what I had for when I read it, and for the chapter 10 and 9 aren't due yet.
Okay. Exercises. Yeah, I see. Oh, I see that. Okay. Yeah. So when I'm going through a list, it doesn't tell. When I'm going through the grade book on and exporting it into an Excel spreadsheet, it doesn't tell me when they were due, just what's been done. So no worries if you don't have a grade for that yet. Some of so you say some of yours aren't graded on Runestone, so they should be at this point. Okay, where does it say 0? Does it say 0 on? Okay, so the score, okay, that's the next thing. After I run the grader, the score me disappears, which causes a lot of alarm for students. The score me never actually mattered. It doesn't give you what, it doesn't grade you. The score me doesn't give you the grade. It just tells you what the grade will be when I run the grader. So it disappearing is not a problem. When I run the grader, it will actually go ahead and manually update your grade. So, so let's go ahead. Let me see. Yeah, so I see that you have like, I'll probably I made sure to regrade a lot of the stuff yesterday, but I'm going to probably regrade them tonight, just to after this class is done. It's mainly it's a thing where I have to go to a drop-down menu and babysit it. It just takes a while. Yeah, I'm gonna regrade the chapter 9 and 10 after I think after it's due. So, but I'm gonna try to run the grader more often, as well as, or I'm just gonna try to read the grader fairly often from now on, since we've got a bulk of assignments. And then there, yeah. So I'll run the grader on the grader for chapter 9 and 10 exercises right now as class is going. So hopefully you'll see your grade update within the next couple minutes if you've done that already. Now with regards to doing your assignments, so Aaron asks, and so did other people in private message me, are we allowed to do assignments on Runestone past their due date? Runestone, yes. I really don't mind when those solo exercises when those get done. As I've mentioned in the past, those are soft deadlines. They are when I expect you to have them done. But if you don't have them done by that time, once they are done, they'll get scooped up in the next run of the grader. And then migrate over to, and then they'll migrate over to the to Zoom. To Zoom. If for some reason, like your answers have disappeared or something, or there were technical issues where you did something, Runestone will log your activities. You can cancel office hours just by deleting your appointment. So, um, so, um, the grade is what you get right or wrong for the runestone exercises. However, comma, you get unlimited attempts to get it right. So um so so there's no reason why you shouldn't be able to get it right. And if you're having trouble, go ahead and you're more than welcome to ask your classmates for that, and then me if we're having further trouble with it auto grading. There's been some where people have had correct answers, but the auto grader was not expecting the answer to be written that way, so it threw a fit. But overall, so, and again, part of also the issue is that I had the grades in the wrong categories. The solo runestone exercises are 10% of the grade, so they're all migrated over there. Anything we do in class, like what we're going to do today, those are worth 30%. The quizzes are worth 30%. So those have now been redistributed, because apparently when I imported the grade categories, it didn't import the grade weights. So that was also a cause for alarm, because for a lot of students, but your grade should now more accurately reflect what your grade actually is. I know I had a lot of students who had A's that suddenly looked like they had zeros, and now you should have A's or B's again, depending. Yeah, the vast majority of you have above an 80. So, okay. And so, and again, if you're missing a lot of these exercises, again, just go through and do them. They're the readings, especially, those are worth, those are free points for clicking a button. So, at least make the effort of trying to participate there. But there is a pretty good correlation with basically, have you done the readings and stuff. Yes, I know that, and I see that nobody has 100% on the solo exercises right now, because I migrated in some stuff that wasn't due yet. It's okay.
You don't understand my fear. When the minute, like 2 days ago, on Sunday night, looked at my phone, saw grades update, and looked at it. I was like at 60 or 70, panicked so hard.
So now let me go ahead and so okay, there might be a couple. So I need to check one more thing. I need to check specifically you, the student who private messaged me, and while I'm doing that, can you get an extension for the hurricane tracker? So when is hurricane tracker due? When did I set that due?
Monday.
Today? Yesterday?
No, it's next Monday.
Friday. Depending on what it is. So let me go ahead.
I thought it was due the 18th.
Yeah, it's due the 18th at midnight.
Some of you may have had a different time. Let me go ahead and change that. So
you guys are talking about the tornado lab.
Hurricane lab. I see that. I'm gonna go ahead and switch it, everybody, to being the 18th. So
yeah, mine was due 15th.
Okay, I've went ahead and I've switched it to be 18th for everybody. And then with the Mario Cash, sure, you can have an extension there. Just email me what's going on. So, okay, now with regards to these, one more student. So the student who said, hey, I just have a 0 for everything. Give me 1 second, because it looks like you accidentally made 2 accounts on Runestone, which is what's interfering there. So I'm gonna have to delete one of those accounts, which I'll do later. And then with you, who just sent me a message, I don't see, and for the And somebody just said, okay, I haven't received any grades for my Runestone assignments, even though the majority of them are completed. I don't see you in the grade book. Okay. All right. And now with the other, so make sure you're registered for the spring class. Yeah, again, I'm sorry about any additional stress or fears I've caused. That was not intentional on my part. I mean, if you've been doing your work, then, and the textbook's been telling you it's okay, then, that would be, I'm not going to penalize you. It's mainly just what's going to happen is that integrate. The problem was integrating these two systems because they don't really talk to each other. All right. Now, with regards to somebody saying, hey, my final score, I've got a lab being dropped. Yeah, I've got a rule in there saying that drop your lowest grade. And if your lowest grade is 100, then I've got to change that with that. But if your grade says but if you've got a grade that says being dropped, it's because I've got a rule in there that says it's being dropped, that you're dropping the lowest one. So it's automatically doing that. So again, there's just some thing. So there shouldn't be worry about it. If you've been doing the work, you shouldn't have any fears. The rule about dropping grades, it's always active, so it always calculates the most. Whenever grades are updated, it calculates what the most optimal drop is and drops it. So let me just go ahead and go to assignments to make sure the proper number of assignments are currently. Right now, I don't want to drop more than one until I figure out what we're doing later in the semester. Active learning says drop the lowest 3, so definitely need to change that. Actually, with the in-class exercises we're doing, that's probably fine. Yeah, it says drop the lowest 3. So of the active learning exercises, which are the ones that have the most, that would have the most detrimental impact on your grade, are being dropped. Okay. So it's automatically taking care of that. And active learning exercises are quizzes and in-class exercises. Sorry, not quizzes. The labs and in-class exercises. Okay. All right. So any more questions with regards to grades? I know I'm really apologetic about any stress I may have caused you. If there's something going wrong with it, there's a couple, like if you have all zeros, there's a couple things that can go wrong with that. One, you didn't do any of the work, which is doubtful, because you probably wouldn't be bringing, because you'd probably know that was why. Two, you may have two accounts. 3, you registered for the fall class rather than the current class. 4, you did not sign up using your name or your TUID number. So with that being said, actually I'm gonna show you as much as I can without violating FERPA of how this works. Because it's also interesting, because it's actually a very interesting lesson for coding purposes.
What does FERPA mean? Because
FERPA, Family Education. It's a privacy act. Basically, it prevents me. It says I'm not legally not allowed to share your grades with anyone else. Or it's the also thing that says that if your parents email me, I gotta say I can neither confirm nor deny that the student is in my class.
I see.
Okay, Dominic, again, things that are having the biggest impact on your grade are currently being dropped. That's what's going on. Okay, so everybody can everybody see my screen at this point?
Yes.
All right, so this is my So here I've got 3 files. I've got Canvas, I've got Runestone, they're comma separated value files, and I've got output. These 2 came from Canvas and Runestone respectively. I just renamed them. Output is what I get when I put them together. I'm not opening them because they have your names, and this goes on YouTube, and definitely don't want to,
So
violate
you
terms.
run code in order to grade the assignment?
Well, the auto grader relies off of the code, code, some of which you'll learn later this semester. And then to merge these 2 spreadsheets, because it's not as simple as copying pasting, I use this thing. I use something called Rune Hash and Rune Emails. So what I do first is I open up the Runestone files with a library called CSV Reader, which makes text reading a bit easier. And I basically say, hey, get rid of the first 2 columns. And then what I'm going to do is that basically I'm going to grab your name. Get rid of the first 2 rows, because those are just simply like this is like first name, last name, assignment name, and all that stuff. And then the second one is how many points there are. And what I do is then I say, I get your first name, get your last name, and then do comma space first name. So I put it in the same format that that Canvas stores your name in. Took me about an hour, I think, maybe less. It took me about 20 minutes to write, and then about an hour to debug, to be honest. I put a lot of thought into how to write it correctly. Most of it was spent thinking, and I was probably watching something in the background. Okay. And then what I do is that I have a file writer over here that says, hey, what I'm going to do is I've got this output file. Now I open all the stuff from Canvas. And basically what I do is I look and see, hey, I get your name from Canvas. I get your email from Canvas. And I look to see, hey, is your name in Canvas? Is your name in the Runestone stuff, in the Runestone information here, this dictionary, which is what we're learning this time around. And if it is, I just go ahead and go, great. Okay, tack all the stuff from Runestone onto the end. Then if I can't find your name, but I can find your email, great. Otherwise, I try doing something with where in Elastic Jetford, I try to remove your middle name or your middle initial to try to match it up. And if I can't find, so that's why I asked at the beginning of the semester, please sign up with your TU email, because that's the one that shows up in the that's the one that shows up in Canvas. And so that makes it easy for this script to do it. And then anyway, after that, that's about it. It's really the magic that makes it easy are dictionaries, believe it or not. Because you notice that basically it's a task that the total number of lines was it was 29 lines long. That's how long it was. Was able to get a lot done in those 29 lines because of the power of dictionaries. So anyway, if you have all zeros, a reason you have all zeros might be because you didn't match one of those things. If you've been doing the work and you have all zeros, then you just somehow became an exception to the rule. Let me know. It could be that your name on Canvas is not your name, right? In which case, let me know, right? People change names. It's a bit of a frustrating thing for programmers that people change names, or that some people don't have names. There's a lot of assumptions programmers make about names, and they're all incorrect. So, okay. So let's. All right. So Matthew, will try to tackle. Let's try to tackle that after class. For now, let's talk about dictionaries. Okay. So I'm going to go ahead and I'm going to go to Runestone and talk about the dictionary. I'm going to talk about dictionaries. So we're going to do an in-class assignment. We're going to try to do an in-class assignment today. If, however, a bunch of you are still confuzzled by this, for some reason, or you're feeling behind, we will abort and I will review this and then we'll resume on Thursday. Okay. Having an so Stephen, having something like VS Code or something else that auto completes makes having longer variable names more viable. So let's go ahead and do exploring common words in SETI. Says you need files, reading file from data, but really what we need is dictionaries. We're also going to be stealing some brief stuff from graphing using a library called Altair, but that's okay. So many projects, they require using something that it requires using a list of the 5,000 most common words. Now, does anybody know how Cat in the Hat was made, by the way? You want to follow along on Runestone. Anybody know how Cat in the Hat was made, by the way?
Didn't someone like
The movie?
dare Dr. Seuss to make?
No, not that abomination of a movie.
Didn't someone dare Dr. Seuss to make like a book only using like the most common English words or something like that?
I believe that is the case.
Wait, there was a movie?
We don't talk about the movie.
It was so bad.
Yeah. So the finished book contained 236 different words. So basically, Professor Kiesel, that for 4, 6, and 7-year-olds who are already mastered the basic mechanic of reading, write me a story first graders can't put it down. As for what? So basically, yeah, it was based off of the whole idea of using a limited number of words. I think the CG movies, the new Seuss CG movies, so you've got the Grinch and the Lorax, those new CG ones, they were actually pretty good. I was actually really impressed with the quality. But we don't talk about Dragon Ball Evolution or the Avatar live action. So anyway, similarly, that used some of the most common words in the English language. Similarly, Thing Explainer, which is a book by Randall Monroe, who writes the webcomic XKCD. He created a book called Think Explainer, which explains complicated stuff in simple words. It uses, I think, only the most, the 1,000 or 1,000 most common words. So there are some interesting challenges that use that, but what are those? Basically, how'd you figure those out? You basically take a bunch of, you can get an estimate. The best you can do is get a very good estimate. So take 450 million words from magazines, newspapers, works of fictions, academic writing, count them up, count each time how often each one appears, and then you'll be able to figure out which is the most common one. Now, I'm not really so apparently what these have to do with each other, common words and SETI, is something called Zipf's law, which is basically saying that words are not evenly distributed across text. There are words that are very common, and then there are words that are very rare. Like the word "are" in the previous sentences. R is a very common word. The is a very common word. A is a very common word. Aliens, not so much. Pedantic, less so. Ziff, very uncommon word. So basically you have very common things and very rare things. So we're going to answer questions to explore this law. I'm not sure if it's the 80. It's not 80-20. Zipf's law said it's a distribution. Let's go ahead, use Google. This is a log-based 10. It's not 80-80. True to Zipf's law, the second place word of accounts for 3.5% of all words. The is the most commonly occurring word, and it accounts for 7% of all the words that you see. That is, so it is, it's similar to Benford's law, which is another fun law I like, but the book supports this one. So, so we've got this really cool data over here. So let's see. It says, so the words on our lists are in order from most frequently used to the least to least, where the rank order is a function of frequency and dispersion. So in other words, it kind of balances it out. In other words, filibuster might be very common in American political science textbooks, but the word filibuster probably won't appear in, say, anything dealing with the UK or a Commonwealth government political textbooks, right? Similarly, function, or rather iteration, might appear in a lot of programming text, but not so much in biology textbooks, maybe, right? There's kind of accounting for, hey, it's common, but also in how many documents it appears. So the project did a lot of like advanced stuff we don't have to worry about, but basically it says, hey, there's this number here which says, so we've got the rank, basically in what place it is in, the word itself, what part of the speech it is, how many times they counted it, and then its dispersion. In other words, in what percentage of the texts it appeared in. So, not percentage. No, that's not percentage. And like what distribution of the text it appeared in. So the appears very frequently. Be, and, of, a, in, to, have. Intuitively, this makes sense that these are really common words, right? So imagine writing a book or article without using those. Pretty much impossible because of the way human communication or communication in general works. There are some interesting texts like let's see, I can't remember, but novel without a, Gadsby. There we go. Not a. It's Gadsby is written without e. It's used without, the entire book is written without using the letter e at all. I know, the things you learn in a computer science class. It's kind of weird. But it's a good point. But anyway, these 5,000. So we have these 5,000 words. So 49.99 apology occurs. 49 doesn't occur too often, apparently, as compared to the. In fact, apology occurs nearly as much as kneel, harvest, and nationwide. So anyway, our first task is to read a file and store it into 5 lists. So split the line into 5 parts and put each into its appropriate list. So we're going to do that here. Basically, what we're going to do is we're going to read this file, and what it wants to do is that we want to store each of these things into a list. Now, why does this come up with dictionaries, or I kind of want to do with dictionaries. I need to double check this. I'm pretty sure this is what we were supposed to do for this week. Module Tuesday. Yeah, it says this is what we're doing for the week. Or this is what I said I was doing for the week. So, okay, I'm going to trust myself from the past. Very bad move there. Okay. So basically we can see that we can disperse this into 5 lists, right? We can disperse this thing into 5 lists, right? We can have the rank, the word, the part of speech, the frequency, and the dispersion. So we can break this into 5 separate lists. So let's read this file and store it into 5 separate lists. So how do we read a file, right? We use open, right? It works in this browser too. This thing is actually a file that's loaded into the browser right now. So it's Word 5000.csv. I'm going to prevent any kind of typos from happening by just copying and pasting. And I'm going to go ahead and do R. And all I'm going to do is I'm going to say text is equal to that. And then I'm just going to confirm it works by saying print text. And what was the function I need to store this into a string, or to take the file and extract it into a string? Dot read. Read. So now I can go ahead and print it. So we see that we've got we've made our page substantially longer. Okay. Let's not do that again. Okay. So we've got this thing, and so now we can iterate line by line. Let's go ahead and let's go ahead and split this up into line by line already. We're using a different function, text dot read lines. And that way I can do something like this, print lines. And now I just want the first 10, please. Be a bit less messy of an output. So here's the first line, and then the second line, and then the third line, and fourth and fifth and sixth and seventh, and all. So there's all the lines, right? Great. Or the first 10. So we need to read this file and store the contents into 5 lists. Remember, as you read each of the lines, the line will be your goal is to split the line in 5 parts and put each of those parts into an appropriate list. So our five lists should be rank. We really don't need rank. It's silly to have rank, but okay. So those are our five lines. Rank, word, part of speech, part of speech. I'm just going to call this part so we can keep everything at 4 letters. Insert joke about 4-letter words here. Okay. So rank part. Okay, part, right? Notice that over we've got A, I, D, X, X. What in the world are these? A is for article, V is for verb, C is for conjunction, I is for preposition. Basically, it's saying what grammatically it is, what this word is part of. Rather than writing it out, it's using a single letter. Okay, so now we've got our text. So what we're going to do is we're going to say for line in lines. And then what I'm going to do, this is going to look a little weird. What I'm going to do is I'm going to chop off that first line. I'm going to go from index 1 to the end. Now, the reason I'm doing that is because, right, we've got this sucker over here, right? We've got rank, word, part of speech, frequency, dispersion. That's not actually any data. That's just telling us what the data is. So I'm reading this. I'm going to chop this off. If you remember, I did something similar in my grade combination that I was doing earlier, right? Where I'm saying, hey, get rid of these first 2 lines. The CSV file I didn't show you because got private information on it. Point is that that's not data. It's the kind of stuff that's telling you what the data is. So I'm just skipping that. And then, okay, it's comma separated. So I can just simply say split. So split. So let's go ahead and do split is equal to, so line.split, that's going to go ahead and take that string and split it and turn it into a list. So if we split this string, it would become 12. That, well, actually wouldn't turn into anything because I got to tell it, you got to split on a comma. So now if we do this, again, printing it out to kind of show where I am. And let's go ahead and limit this again to limit the output so that we don't. So I went ahead and split this up. So let's go ahead and say basically, so now let's go ahead and take our parts and add them. So rank is equal to, or rank. So there's a cool function we have to add something to the end of a list, rank.append. We're going to go ahead and append int line 0. That's this item over here. I'm transforming it into an int because it's a number, so that makes sense to do. And then let's go ahead. What did I mess up? I messed something up. Yes, I messed up not having enough parentheses. It's like got a spider sense about those things. Word dot, and then so let's go ahead and copy paste this because honestly, this is where it's going to be very repetitive very quickly. Okay. So let's go ahead. So 1, 2, 3, 4, 5. So we've got 5 parts to this. So dispersion. And rather than being an integer, we're going to transform this into a float. This is the frequency. That should be turned into a, that should still be turned into an int. And then we've got our part of speech and our word, which don't need to be transformed into anything. Okay, and now print rank word part freak disp. So I'm going to print out those 4 lists together. So we've got, so now our output, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got the, be, and we've got the words. We have their parts of speech. We have the frequencies they occur at, and we have the dispersion. So we have this split up into all the lists we want, which is cool. One thing we can do with this is that we can do, what can we do here? We can do make use. Now printing that out didn't look too pretty, so I can actually, there's actually something I can do right here, which is so if you remember, there was a special word we had to enumerate. I'm just going to call it thing. I'm going to do basically another cool trip you can do. Zip, and then let's keep this. So I'm going to go ahead and instead of saying that, I'm going to say zip for thing in zip up all those lists. What in the world? Zip, right? Print thing. But it's apparent as to what zip does. The plus equal would work if you cast the thing into a list. So zip basically allows you to go iterate through multiple lists together at the same time, item by index by index. The requirement is that everything becomes the requirement is that every list you're using in a zip is the same length. As a bonus, ran across a XKCD that many on liberal arts campuses may. So the word sustainable is unsustainable. So frequency of the word sustainable in the English text as a percentage of all words by year. So notice in the 1960s, sustainable wasn't really used that much. And now it's getting used more and more often, present day. And if we plot this out in a line graph, which is always a dangerous thing, by 2036, sustainable will occur on average once per page. By 2061, sustainable would occur on average once per sentence. And then by 2100, we're doomed because all sentences will just be the word sustainable repeated all over and over and over. So So first, let's look at what fraction of overall usage the 10 most common words represent. One thing we need to do to accomplish this is to turn the frequency count for each of these into a percentage. Once we have a new column for a table, we can sum up the percentages for the first 10. All right. I mean, it's not so much new energy we need to invest in. I mean, we've got this giant ball of fire that's giving it to us for free. All right, so I will go ahead and share the code for the first one. All right. So what we need to do is that we need to look at what fraction the most, first, let's look at what fraction the overall usage of the topmost 10 common words represent. Okay, so the first thing we need to do to accomplish this is to turn the frequency count for each word into a percentage. So right now we've got, these counts over here, right? We've got these big numbers over here. We want to take these, we need to take these and turn them into, we need to turn these into percentages. So let's go ahead and grab everything we have over here. Right? So we've got all of our lists over here. Share this again. Now calculate the total percentage for the top 10 words in the list. Store this result in a variable called top 10. At the same time, calculate the percentage for the bottom 10 words in the list and store those results in the bottom 10. So in other words, we want to know, like, okay, do these top 10 words, which are the, be, and, of, in, to, have, to, and it. Now, why do we have two twos together? T, the infinitive to, and then 9 is the preposition to. And I just did share the code. So what you're going to want to do here is we want to find out what percentage is this actually in the human language? Is this like half of all the spoken words? Is it a quarter of the spoken words? Well, to do that, you're going to have to add up you're going to have to find out how many total words there were in the corpus that we examined. So in other words, adding up all the numbers in this. And then figuring out that and then translating that to percentage. I'll give you a hint. Right? You'll want a list called percentage. Okay. So go ahead and try a hand at it. Sorry, I'm just checking in the future what's going on. Okay, yeah, I'm going to go ahead and I'm going to go ahead and look up what I did last semester.
really a matter of if you want to come or not?
Yes.
So tomorrow.
I can go over tomorrow as well as today. All right. So let's go ahead and we need to complete this part and do the top 10 and the bottom 10. First thing we need to do is we need to translate these frequencies into a percentage. So first, let's find out what the total number of words are, period, in this corpus. Total is equal to the sum of all the numbers of all the words. So if I do sum of frequency, this would give me the total number of all words that they counted in their entire in these top 5,000 words. So print total. I'm interested in seeing how big of a number that is, because it's so we have a grand total. So this counted a grand total of 101. Let's see, 303,000, 87 million. 87 million words and change in the corpus. So it's a lot of words. I think that's like almost as long as the entire Wheel of Time novel. So anyway, it's a joke. So let's go ahead. So now we're gonna need that total, because we need to turn everything into percentages. So for count, so for the number count in frequencies, we're going to take the count and divide it by the total. So like, right, this is the number of times that specific word occurred, divide by the total number of times that occurred. And we'll just simply say percentage is equal to dot append count dot total. Okay, and now what we're going to do is that to get the top 10, we're just going to simply say top underscore 10 is equal to percentage. I mean, well, we'd want the top 10, so 0 to the first 10. So unsupported operands for types for sub, list, and float. What's going on there? For count and freak. Okay. What's going on there? What did I do wrong? Unsupported types for sub. Well, where's that occurring? Being less than helpful here. Name top 10 is not defined. Save. Okay. Let's go ahead. Okay. Oh, duh. Okay. So let's go ahead and run. So now, first off, before we go on to this, I was being dumb. All right. So now, so if we look at this, it seems like the occurs for 25% of all the words in the language, which I was kind of emphasizing how much I was saying the. And then and B occurred about half as much. So in total, the top 10 words would be right. And we're looking for a float here. So we want to know how much total the top 10 amount to. Okay. Expected 1 point actual value, expected value. Interesting. Expected 1.0 to equal 2.7.
It's because you added up all the percentages, right? Equals 100%.
Sorry?
Because
Overall,
because
first thing they need to do is accomplish frequency count into the word into percentages. What did I do different here? What did I do that was dumb? What did
I think Freck is only being given the first 10 because of that first for loop.
Oh. Duh. There we go. That's my issue. Yeah, I was only doing the first 10. Okay, so the isn't 25% of all the words. All these top 10 words together are about 27%. So what is then?
What did you have to change right there?
Let's see. Sorry?
What did you just change that you said seemed
Yes.
obvious? Oh, got it.
Yeah.
Yeah.
So the amounts for 6% of all words. That seems to be much more likely. All right. And so for the bottom 10, we can just simply say, hey, negative 10 to the end. So, and that should be bottom 10. Okay. Save and run. So there we go. And so the bottom 10 words of the 5,000 words account for 20%. Sorry, so this is 1%, 100th, 1,000th, and a half percent. All right, to get a sense for the distribution of words, we're going to use something called Altair, and I'm just going to copy paste. So I'm going to share this. And I'm going to definitely share the next one because it is something I'm going to copy and paste. Get a sense for the distribution of words. Let's use Altair to graph the frequency of the words on the y-axis against the rank of the word on the x. So you'll see a pretty dramatic curve. It's also not very useful because you'll see. So so here I'm going to dump in a bunch of files I had from last semester just to save us some time. But what this does is that I'm using a graphing library supported by this website called Altair, or Altair. So, and what this does is that basically we are, so what am I appending? Line 1, turning that into a base 10 number, I think. And then frequency, I'm taking the logarithm of that. Log of the frequency and the log of the rank. And then save and run. But we get this graph basically saying, what's pretty cool is that it's just a little bit of code over here that basically takes this and puts it into a graph like this automatically for us. And what it's saying here is like, here's the frequency of it. So this is the percent. So the occurs 7% of the time. And we see that basically that these numbers occur, not too often. They occur, once, let's see, is it 1% of the time? Doesn't seem right.
Just wondering, how do we get the bottom 10%?
The bottom 10% comes from this. Oh, sorry. Bottom 10% comes from this over here, where I simply said grab the -10.
Okay, thank you.
Mm-hmm. So with that though, I wanna actually turn towards a so with this, I think I'm gonna stop here for a sec and you can try these over here because I want to turn the discussion towards dictionaries for a second here for our last 20 minutes. Which is great and all, but like how do you actually count how often these numbers occur? Right. This is interesting and all, but how do you actually do this, like counting to see how frequent words are? Right. Suppose you wanted to like, okay. So again, let's grab something that's fairly substantial. Project Gutenberg, complete works of William Shakespeare. I'm going to grab that again. Okay. Right. That's a fairly big file. It's 5 megabytes long. So let's go ahead. Oh, got it. So it's called shake.txt. It's over here. I'm going to go ahead and work on in the desktop. I'm going to create a new file. I'm going to go ahead and create a Python file. Word counter.py. So we're done with the in-class exercises. I'm going to go ahead and share that. I just wanted to do, because I want to focus on this part more. This assignment doesn't, it's interesting, but it more focuses on the file reading and less on the other stuff I want to focus on. And so I'm going to adjust the grader for this one accordingly. Okay. Maybe Assassin's Creed. Okay. So let's go ahead and see. So let's go ahead and open up our Shakespeare file. So let's open up shake.txt. Put it into read mode. Okay, and text is equal to shake.txt. Great. Now for line in text, right? Print line, and this will just print out this spits out the entire file, which takes a while until it says I can't decode the byte because it's a weird byte. So again, I'm gonna say, hey, this is a UTF-8 file. Again, you normally don't have to put this on. It's just from these files coming from Gutenberg because they support UTF-8. There we go. I'll go ahead and drop this text file in chat. Yeah. Send to everyone. Text. And it takes a while to print out, as you can see. A long time. So the question is, if I wanted to go through and count the most common words in this, how in the world would I go about doing that? Right? Because we don't know what variables are occurring. We don't know what's occurring. We don't it'd be very tedious to go num thes, right? And then say, hey, if I see a word that, if I see a the, I'm going to increment the num thes by 1. I don't know how many there are, right? I did share the code for Last Thing on Runestone. Okay. Next, let's go ahead and take a look at how we might do that. The way we get around that is to use something called a dictionary, also known as an associative array or a hash table. It's a pretty awesome data structure. Essentially what this allows us to do, and I'll show you in Python over here, what this allows us to do is that it allows us to, I will double check that when I go at the end of the lecture. I should have shared it. Okay. Runestone. So, but if I didn't, I'll reshare it at the end of the lecture. So how does a dictionary work? Well, dictionary works like a list, except the indices are made up and order doesn't matter. By which I mean is it basically looks like a list except with curly braces instead of brackets. Okay. So and what I can do is that I can basically say, hey, at index 2, I would like to put the number 50. And this creates an association, a binding between the key 2 and the value 50. We don't call them indices, actually. We call them keys in this context. So given the key 2, I'm going to get 50 back. Given the key 100, I'm going to go ahead and put 100. Right? So 2, give me 2, I'll give you back 50. Give me 100, I'll give you back 100. I'll give you back the word 100. So if I can say D2, I'll get back 50. D100, I'll give you back the word 100. But that's not only what you can do with it, right? You're not because when we're again, it's like a list, except you can use almost anything you want as a key. Yes, it is pretty much identical to what you would see in JavaScript. These exist in pretty much every single programming language because they are so powerful. So for instance, I could put, I could use basically this key, favorite color is equal to blue. And now if I ask for, so 2, the key 2 gives me 50, 100 gives me 100, and favorite color would give me blue. So if I go ahead and ask for this, if I say, give me what's associated with the key favorite color, it'll say blue. If I try to give it a key that doesn't exist, it'll just simply say, hey, that key doesn't exist. Right? So basically allows you to kind of basically make things up on the fly. This is kind of useful. Now, dictionaries are used in basically 3 separate contexts. You'll learn them in a great more deal if you take 2168. But for those of you who are just taking this for the heck of it, I should probably explain it now. So you use dictionaries in 3 contexts. One is key value lookup pairing, which sounds really abstract, but basically it's saying like, given a unique identifier, like the customer's email address or a social security number or something like that, retrieve all the data that is associated with that. Given a student ID, retrieve all the information for the student, right? So key value lookup like that. So it's a kind of a nice database kind of abstract database kind of deal. Another thing a second thing this is used for is counting. So given that you want to count stuff, but you don't know specifically what you want to count, you can go through something and when you see it, you can count it, like words. Say you want to count the number of times each word appears, right? We could say the key is the word and the value is the number of times we see it. The first application was key value lookup. So basically, given a unique identifier, give me the stuff associated with that. So like a student ID, give me the student. Given a student ID, give me the student, because sometimes name doesn't work because names are not unique. Okay. Third usage is categorization, saying this is given the key, that the key is the category and the value is the list of all the things in this category. So we're going to see this counting application now, which is by far what you'll find to be the most useful. So here's my count. What I'm going to do is I'm going to say, hey, for every line in the text. So first, let's go ahead and let's go ahead and do a couple things here to sanitize our text. So line is equal to line dot strip. So this gets, again, rid of all the beginning and ending text, like all the beginning and ending white space, right? So if I get a line like this, it will, where I get the title like that, it'll get reduced to just title like that, okay? Second thing, so that's the first thing I want to do with there. Second thing I'd like to do is line to, I'm going to go ahead and convert everything to lowercase so I don't have to deal with with any madness about converting anything with uppercase and lowercase. Next thing I want to do is, now that I've got that, let's go ahead and split it. Actually, if line equals the empty string, I'm going to use a special keyword here, continue, which just simply means skip to the next line, skip to the next iteration in the for loop. I don't want to bother continuing with the code otherwise. So because what I'm going to do over here is say words is equal to, I'm going to take the line and split it into words, right? Every white space I see, I'm going to go ahead and just split it into I'm going to separate everything by white space. So for every word in words, now what I can do is I basically can use some very useful techniques over here. So it's going to go by a bit quick because, again, if you want more background on this, you check out the videos on this and the textbook readings, because we're going to be focusing on this on Thursday. So count. What we want is to count the word. So I've got a word now. Question is, have I seen it before? Right? So is this word in the count of words? If it is, then the count of that word, I've seen it one more time, so I'm going to so let's go ahead and actually make it a bit easier to see, because that's a bit, so let's go ahead and say, what if the word is not in count? So so I take the line, I split it up into going word by word, and I ask myself, is that word in here? If the word is not in here, if I've not counted it yet, because I haven't seen it yet, this is the first time I've seen the word Hamlet, then I should add it to my count. Count of this word is equal to 1. I've seen it once now. Else, I have seen it before, so I'm going to say count of the word plus equals 1. And now I'll just go ahead and print out that dictionary to kind of test that it works. And so we can see that the appears 30,000 times, project appears 91 times, Gutenberg appears 24 times. So, and this weird thing of the occurs, that's some Unicode nonsense occurs once. So, all right. What we're gonna do now is there's some other stuff that we have to deal with though. Like we've got reuse with the dash. We've got lovest, which is fine. We've got some stuff with a comma. I think we have stuff with commas afterwards, like well, comma.
I have a question. Are the numbers that are after it like brag? It was like brag colons 13. Are those the amount of times the words come up?
Yes, that is exactly what this is in this context.
Whatever you just did not look like it.
It is the number of times that word has occurred in this document. So if word not in count, so first what we want to do to get rid of these commas at the end or something is like, let's see, do we have a function that might help us? Word dot replace. Let's see what replace does. Method, replace old string with new string. So I could replace the commas ostensibly. I'll just keep it for right now. That's fine. It's not going to really impact this too much. But now we've got, so let's go ahead and instead, what I'm going to do is print for word in, I'm going to print it out a bit nicer, for word in count. Print print word and count of the word. And so that prints out all the words and how often they appear. Or all the words that we found and how often they appear, which it's a lot of them apparently. So yeah, that's kind of how you would be able to and I think it's a lot of these are interesting that they're coming up like this. Let's go ahead and can you write this dictionary to a text or CSV file? We sure could. We can write this to a text file. So let's go ahead because we've got a nasty amount of output. So let's go ahead and say open counts.txt. Let's call it CSV anyway. Counts.csv is equal to and we're going to put this in write mode. Output is equal to this for word and count. And what we're going to do is we are going to just simply say output dot write. We are going to add the word. We're going to add, and we're going to concatenate that with a space. And we're going to have to turn this into a string. And then we're going to add a new line to the end, and that will output it into a word for us. Why are you saying string? Expected parenthesis. You've got a parentheses. What are you talking about? So
do you need a plus after the or before string?
Oh yes. Karma. Yes. Let's go ahead and say this is encoded into UTF-8 file because I'm having that issue. And let's go ahead and it says it's done, surprisingly, very surprisingly. Counts.csv. So for some reason, it's not broken up into cells. So let's go ahead and instead, we're going to just do commas because it's a CSV file. Amazing how much quicker it takes to write rather than it takes to takes a lot. Interesting. So this is comma. This is suffering from the fact that basically that this is Shakespeare, comma. We didn't pick that up. So this is where basically we have extraneous commas kind of interfering with an accurate count. But notice that here that was ending with the period is being counted as distinct from was without a period or a comma. Which is an issue, but one we can deal with. And now we should be able to let's see, can we? I don't use Excel too often, but I should be able to sort them, right? So let's see. What is that? View. How do I sort? So I'm not unashamed to ask. How would I sort by this? How would I sort these two columns by B? Go to the data tab and click sort. Right. So sort is there. Sort from, let's see. Nah, I don't want to sort from A. I want to sort from B. Or should I just sort this guy? Well, that's sort. Yeah, this tells you exactly how much I use Excel, which is like almost not at all. I know what it can do. I just don't use it. Sort column B. Let's see. The issue is that I've sorted it smallest to largest, but it isn't taking the words with it, which is a shame. Highlight B, click sort. Interesting. You know what? That is not something I need to worry about today because it is already 3:20. But point being is now that we have this, we can sort it. We can also just simply do that in Python with a way to just simply output it in a sorted order instead, which might be simpler. In fact, for me, it is simpler, but it's 3:20.